relativity. That's a way of understanding the biggest things in the universe. Things like stars and galaxies. But the littlest things in the universe, atoms and subatomic particles, play by an entirely different set of rules, called quantum mechanics. These two sets of rules are each incredibly accurate in their own domain, but whenever we try to combine them to solve some of the deepest mysteries in the universe, disaster strikes. And see the cosmic film in its entirety. Well, a new set of ideas, called string theory, may be able to do that. And if it's right, it would be one of the biggest blockbusters in the history of science. Someday, string theory may be able to explain all of nature, from the tiniest bits of matter to the farthest reaches of the cosmos, using just one single ingredient: tiny, vibrating strands of energy called strings. But why do we have to rewrite the laws of physics to accomplish this? Why? But before we can find that theory, we need to take a fantastic journey to see why the two sets of laws we have conflict with each other. And the first stop on this strange trip is the realm of very large objects. To describe the universe on large scales, we use one set of laws, Einstein's general theory of relativity, and that's a theory of how gravity works. To understand the universe on extremely small scales, we have to use our other set of laws, quantum mechanics. And as we'll see, quantum mechanics paints a picture of space so drastically different from general relativity that you'd think they were describing two completely separate universes. General relativity and quantum mechanics, we need to shrink way down in size. And as we leave the world of large objects behind and approach the microscopic realm, the familiar picture of space in which everything behaves predictably begins to be replaced by a world with a structure that is far less certain. We keep shrinking, getting billions and billions of times smaller than even the tiniest bits of matter, atoms and the tiny particles inside of them, the laws of the very small, quantum mechanics, say that the fabric of space becomes bumpy and chaotic. Eventually, we reach a world so turbulent that it defies common sense. Down here, space and time are so twisted and distorted that the conventional ideas of left and right, up and down, even before and after, break down. There's no way to tell for certain that I'm here or here, both places at once. Or maybe I arrived here before I arrived here. In the quantum world, you just can't pin everything down. It's an inherently wild and frenetic place.
The laws in the quantum world are very different from the laws that we are used to. And is that surprising? Why should the world of the very small at an atomic level, why should that world obey the same kind of rules and laws that we are used to in our world with apples and oranges and walking around on the street? Why would that world behave the same way?
The fluctuating, jittery picture of space and time predicted by quantum mechanics is in direct conflict with the smooth, orderly, geometric model of space and time described by General Relativity.
The laws in the quantum world are very different from the laws that we are used to. And is that surprising? Why should the world of the very small at an atomic level, why should that world obey the same kind of rules and laws that we are used to in our world with apples and oranges and walking around on the street? Why would that world behave the same way? The laws in the quantum world are very different from the laws that we are used to. And is that surprising? Why should the world of the very small at an atomic level, why should that world obey the same kind of rules and laws that we are used to in our world with apples and oranges and walking around on the street? Why would that world behave the same way? The laws in the quantum world are very different from the laws that we are used to. And is that surprising? Why should the world of the very small at an atomic level, why should that world obey the same kind of rules and laws that we are used to in our world with apples and oranges and walking around on the street? Why would that world behave the same way?
Cultural modus operandi. Every parent and child worldwide shall leave the motion picture theater knowing that they have seen much farther than Einstein ever expected, but nonetheless that they have seen Einstein's vision and beyond. And that Einstein himself seen in the film with child prodigy from Japan, Philippines, Europe, Islam, Scandinavia would agree wholeheartedly and explain clearly to the world where his shortcomings were. There will be nothing abstract which children kindergarten through 8th grade cannot readily understand and be moved by, and which would not be endorsed by Hans Albert Einstein, the son of Albert Einstein and the proven friend of Timothy B. Cryer O'Boyle, the first child prodigy.
The laws in the quantum world are very different from the laws that we are used to. And is that surprising? Why should the world of the very small at an atomic level, why should that world obey the same kind of rules and laws that we are used to in our world with apples and oranges and walking around on the street? Why would that world behave the same way?